Hello everyone, this is Dr. Angelo Arguson and welcome to my latest video for Python course. Today's video focuses on data analysis on a specific dataset. And the goal for today is definitely to acquaint yourself with the dataset provided and extract information to explain the patterns and trends discovered. So definitely we will do an EDA or exploratory data analysis on the given dataset. So in this session, I'm going to use one of the interesting and exciting to analyze, okay, the data set that is called Titanic. Okay. Here, I gathered or obtained the data set from Kaggle's official website. Okay, and according to them, okay, the data set is up for grabs and definitely you can actually participate on competitions that involves the said data set. The data is actually also provided and it was being split into two groups, okay, the training set and the test set. Now, in this video, you'll also being able to see the data dictionary of the data that we are going to analyze for this tutorial. And there are some other what notes, okay, under some of the features, okay, of this data. And there are some actually one of guide about feature that you might be interested to know, like for the age, SIB SP, okay. SIB starts for means a sibling. It can be a brother, a sister, or stepbrother, or stepsister. SP stands for spouse, okay, husband or wife. And parch means the data set defines family relation in a way such as being a parent or a child. Okay, those are actually in the data set. And P class stands for the ticket class. Survival means where zero is equal to no or did not survive or perished. And ones means yes, they do survive. Ticket class means so number one is the first class, number two is the second class, and three dictates that they are the third class. Or okay, so that's the data that we have, okay, how they define it according to their website. Now, what we are actually uh, what interested to do to start learning it using our Python programming language. Okay, so here we're going to run a pandas PD. Okay, we're going to import it. Okay, definitely one of the main reason we use that is because we use that library for working with the data set that we have. So using the pandas, okay, it has this function for analyzing, cleaning, exploring, and do some manipulation on the data. Okay. One more trivia about it. Okay. The name pandas has a reference to both panel data and the word Python data analysis. And that is again the reason why we name it as pandas. So again, we need to import that on our program. Next, on this notebook, same notebook, we need to import Seaborn, okay, library, because we definitely need some plotting later on, okay, or graphs to be displayed onto our notebook. We also have this matplotlib, okay, for pie plots and styling, okay. If you wonder about having the matplotlib in our notebook, well, there's a reason for that. We really need the function of it in uh, inline mode. Okay. So matplotlib, okay, function in inline mode is a feature that allows you to display generated plots directly within the Jupyter notebook environment rather than having it on a separate window. So if you're going to enable inline plotting in a code, we typically use a percentile matplotlib inline, okay, magic command. So this command is placed at the beginning of the notebook and informs the matplotlib, okay, these two lines that we have here, to render the plots directly, okay, below the code cells. Next, here we have a code to specify the file path. Okay, and since it might be long on my end, definitely I have to put it on to separate lines. Okay, so here I have divided it to train and test set. Now, if you happen to get some projects that was given to you as one whole data set that are not being divided into two, then you'll have to split it that way. Or you may also use some library like scikit, okay, to make a split of those two to provide you a test and training sets. With that, okay, you can separate it into ratio. So what's the ratio? You have to, by default, the rule of thumb is definitely you'll have to split it by 70 to 30% or 80 and 20%, where the train has to have a bigger portion than the test data set. Okay, so what's the reason for that? Well, one of the key aspect of the supervised machine learning like this is model evaluation and validation. So when you evaluate the predictive performance of your model, it's essential that the process be unbiased. So using the train test split from the data science side, learn, you can definitely split your data set into a subset, okay, that minimize the potential for bias in your evaluation process. So splitting your data set is definitely essential for unbiased evaluation of your prediction performance. Okay, if you're going to run some predictive classification, okay, then machine learning, then definitely you'll need to do that. Okay, so in most cases, it's enough to split the data set randomly into two subsets. Number one, we have the training set. Okay, so the training set is applied to train or fit your model. For example, you use the training set to find the optimal weights or coefficients, okay, for regression or neural networks. And then we also have the test set. Okay. In here, we call it as test DF for data frame. So we need the test set for unbiased evaluation of the final model. So you shouldn't use it, okay, for fitting or validation purposes. So DF stands for data frame. So in here we have the file path being set for our train data frame and test data frame. Next, in here I also have info. Okay, so what is this info? Well, definitely this train set, okay, that we have here will be displayed with their respective features. Okay, we now have columns, okay, such as passenger ID, survived, P class, on and so forth, until we get to the 11th element or the 11th column named as embarked. And each of these are being described according to their data type and if they do have some null counts, okay, on it. Next, you can see that some of them are not really an integer, and that's actually our challenge for today's session. We're going to convert them into numeric value for better training. So we have a summary here of the data types. Okay, we have two floats, five integers, and five objects. Next, we have here the method named as describe. So what's the purpose of having this? Okay, this method returns a description of the data in your data frame. So since our data frame is a trained data set, it will only describe that data set alone, not the test. Okay? So in here we do have some statistical uh, analysis of the features that we have. So we have here passenger ID of 624 being counted. A total of 624 was labeled as survived. But in here, we're still having some missing values for the age, which is actually what indicative that we have this data. anomaly. Okay, we need to supply those values that are missing. Okay, yes, there's disparity on the value. Then we have here a mean of 312. So definitely, even if they do have passenger ID, well, they are being counted, but that's not really much more interesting for now. But what we are actually trying to observe here is actually the age, okay, that is actually being measured or calculated here. The distance or the standard deviation of the age that was able to be recorded, okay, was 14. Next, we also have the minimum value, okay, of age is 0.75. So definitely it's a child or a baby. Okay. Next, what's the maximum age? We have 71 years old. Okay. Next, we also have here the train for head. Okay. So what is this? What does this head method do for us? Okay, so the method head returns a specified number of row string from the top. So if we have records being kept in the dataset, then we will only display 10 records out of those total number of rows or records in the training set. So in here we have 0 to 9. Yes, 0 to 9 records, okay, being flashed on our screen. Okay, so we have here the values, okay, individual values per row. So we're trying to pick in the first 10 records here. Okay, so we can see here there's this zeros and one. There's some values that are NaN. This means that they are still not a number and they are being kept onto the data set. So these are the things that we need to clean on this data set that we have. Okay, it is actually in a raw form and definitely will need to clean them, supply the missing values, and then be able to supply a better value that is actually being used for better training later on. Next, head. Okay, so I use this head definitely to provide me a value that will be returned as a specified number of so definitely when we have this head a while ago, I'll try to use at least test head for the testing data set. Okay. So maybe you might be wondering, oh, we only started with the passenger ID number one, but what's under the head for test data set that we have? So in here we started with 625. So that means we're using 70-30 split, and that the 30% was starting do start at 625 passenger ID. Then if you happen to look here, there's still some numbers that we need to clean under the cabin feature. Next, moving on, we have this column values. Okay, so I did this line so I can see all of those features not only in this way but also in this in an array form. Okay. Next, I prepared some codes here that will allow me to compute all the missing values, okay, per feature. So we're going to compute the total of each of them. Okay, make sure that if it's null, then definitely add them up. Okay, and then recompute the total, and then we get the percentage of each of them. Okay, using these two variables that we have prepared. Okay, if it's a null on the training set, then we're going to get the sum and then divide them into the number of total, and then multiply it with 100 to get the 100%. Okay, and then we have this missing data that we will be using for the display here. So using the missing data will be dependent on this line where we will be having the total percentage, okay, the total and the percentage symbol. So this will be used as the headers in here. So we have here a total of 484 uh, missing or null values, which actually made up the 77%, okay, of missing values under the cabin, while there are 131 missing age values, okay, under the age column. So that makes up 21% uh, of the total in the data set. Next, we also have one instance on the embark. So definitely one from this, oh, that one under passenger 62 was the missing value. So this is actually the another way of giving us an idea to familiarize with our data set. Now, what I'm actually going to run here is to provide you visualization, okay, that will plot them into charts and be able to get a better understanding of the trends, okay, and patterns that we are going to see onto the data. So what I prepared here is to have these two variables, one for the survived and the not survived or perished. And we have to plot them onto figures and axes that we have here. I have here a variable for women and men that will be uh, what set or to prepare an array for collecting the numbers of female in in the training data set, and then also obtain all the males, okay, under the train data set. So we're going to have that, okay, one women array and an array for a men. Now this is actually our way to have them being displayed, okay, onto our plot later on using a distribution plot, okay, to really display it on to a separate box. Okay, we will also do write this legend and set title. Well, the set title is actually accepting a string value for you to prepare what will be the title of your your plot or your chart. And the same code will also be repeated here, but you have to change some of the values for the distribution plot. Okay, for the men, okay, men gender, and try to specify the label to survive and not survive, just like what you have done with the female. Okay, so axis will be 0 for the female and 1 for the male. Okay, there. Next, this will be the output of that program. Okay, so what do we have here? This explains the distribution of survivability through their genders. So most of the time here you can see that all the female, okay, most of the female rather do survive during that incident. Okay, it is depicted by a blue color to provide you the meaning of those chart. So you can see that most of the survivors are around 20 and above, okay, for female. Okay, and the not survive or a person who perished are in a lower rate, irregardless of age. Now looking at the male, okay, under the male category, okay, most of them did not really survive. Okay, so they are all gentlemen that gave way to the youngsters and also to the female uh, passengers, to survive. So they prioritize the female and the younger ones. If you happen to look here, for the male, the ones that have the highest rate of survivor instances of surviving were under the infant group or the child category, which is less than 5 years of age. And if they do survive more than that, they must be around uh, nearing 25 to 27 years of age in order to survive. And the next survivor that are actually in the adult group are almost in the age of 35, 32. to 30 35 years of age. So that's it. So if you wanted to really dig deeper, okay, to this chart, then definitely will definitely introduce you to another way of plotting. So we have here the point plot, okay, with the help of facet grid. Okay. This time, when we do point plots, we need to have at least three. We need three features to be an input, okay, to this. But anyway, before I do that, what's this facet grid that I'm telling you? Okay. A facet grid, according to their website, is a multi-plot grid used for plotting conditional relationships. In this case, our uh, features being on point here are the P class, survived, and gender or the sex. Okay, definitely, we will try to look into these variables, okay, about their relationship, conditional relationship. Okay. So I have here some notes here. Okay, C for Cherbourg, Q for Queenstown, and S for Southampton. B class is actually again the ticket class. Okay, so if we have to look at this point plots that we have here, we can see that those who embarked from Southampton, okay, has a high survivability rate on the female. Okay. Notice that if it goes one, then that definitely that's a perfect uh, probability. But then again, under most of the female who embark from Southampton has higher succession rate. Now, what's with this points here? Why they are divided into three? Well, it depicts their class or P class or the ticket class that we have. So if they are having a higher class of ticket, then there is a higher rate of survivability. Now, if you happen to notice, those are in the third class, okay, they have at least 40% chance of survivability. And the male are still, as expected, has a lower chance of surviving. Compared it with the Cherbourg passengers who embarked from Cherbourg, most of the male, okay, were able to what? To survive. And at least you can see that those at uh, second class tickets were perfect, or all of them, all of them were able to survive. And almost all of the male in the first class did survive. Okay. So most of the Cherbourg passengers who embarked from Cherbourg were higher success rate, okay, or survivability rate, okay, if they are a male. Now, that's not actually the same scenario for the female. As you can see here, the highest chance is to get at least 35, okay, or 30%. On the Queenstown, okay, it's actually a different story now. Most of the female, okay, who embarked from Queenstown were able to survive than males. Next, if that is not enough, okay, maybe we can run a bar plot, okay, using an SNSC born module. Okay, and in here it just need two, okay, features or variables that you need to supply here. So we have, in this case, since P class definitely is actually the one that contributes, okay, to survivability, then we're going to use that, okay, to check on the survive or output variable. We're going to inspect that, okay, since we have seen that there's this influence, okay, of being able to survive using if they have the P class or if they have a ticket class. So let's see if they do have some effect or influence, okay. And as you can see here, it has a direct influence on survivability. Most of the most of the time, okay, almost 60%, okay, in here, you get to see that if you have a higher ticket, there's actually 60% most of the time of survivability, and at least 50% for second class ticket rates, and third class ticket rates will be around half or 25%. Okay. Next, let's try to look at much deeper on these plots, okay, that we have seen. So definitely, if we have the class and survivability being observed, let's take that into account under the age now. Okay, so let's have the age being part of the factor. We have here a histogram, okay, that we will use. So definitely, we'll have the age survived and the P class. So in here, definitely we'll have what, two columns and three rows of the plot. So let's make it clearer. Okay, let's see. So in here on the left, we get to see the survive zero label and survive one. So what do we mean again by a zero? Definitely we have this from our listing a while ago. If it's zero, it's a no. Okay, if it's one, it's a yes. Okay, so let's see. So most of the time, okay, so those who perished or did not survive, there's actually a large frequency on the age group, the age group of the third classes. Okay, so most of those um who perished were under the class number three, and they are around age uh teenage group up until 20s to 30s. Okay, most of them do perished. Okay, with the P class of three or the third class tickets. Okay, and those who have uh what, ticket number one, okay, were able to survive, but with a lower frequency. As you can see here, the distribution shows that it's small, almost, okay, around the age of 30s who were able to survive if they were holding a passenger ticket class 1. Under the ticket class 2, it's almost moderate. Okay, the frequency is around 10. Okay, it's actually well distributed, but if you can see here, the age group is around most of the time uh do fall for the youngest group and also with the 30s. Now for the third class ticket, who holds the third class ticket, they will be able to survive more if they are around the age group of this, the infants or the babies, and also with the 20s group up until to the mid 30s. Okay, there. So that explains the trend, okay, of survivability. So we can now get an idea from this data that we are getting from the Titanic's data set. Okay, people were gentlemen and definitely gave way to the women and the younger age groups. Okay, to survive. Okay, they prioritize those women and child. Next, definitely will have to understand better that the the relationship of having the child and the parent, since if you can see here, most of the in the third class do provide a data that if they are in the young group and in also in the second group, they will be able to survive. Well, let's see how they correlate onto relationships. So in here we have set up a data set for providing uh relativity, okay, or the relatives, okay, of each of them. So if they do have a relatives, then we will have one. Okay, if not alone, then we'll have a zero. So those are actually the things that we did here. So if it's a 1, definitely we have 365 instances and 0 of 259. So again, here is actually this code for the 0. Okay. So if we have a relative greater than 0, then it's definitely not alone. If their relative is equal to 0, then they are 1. Okay. So what's the reason for having this? Definitely we'll have to set it up for our next plot, okay, that we're going to use. I'm going to use a factor plot this time, okay, for the relatives and survive. Since the relatives, the one that we have created a while ago for using this code, okay, definitely what we wanted to inspect here is that if we have to factor in the relationships of having these kids and also these young adults and the adults group, okay, then definitely there is a chance that they will be able to survive together. So let's see. Under this result, we get to see that, okay, if there is actually an instances, okay, of relatives, okay. So in here, we get to see they will be able to survive if most of the time they have more than three. If they are having three in the family. But if they add another one in the family, they are not alone, they're more than three, the survivability falls down. And if you happen to see if they have seven in a group, in a family, 7 to 10, there's actually no chance of them being able to survive. So definitely the most ideal way to survive is when you are at three members in a group or in the family. Okay. So there, that's actually one way of observing the siblings or parents, okay, relationship in here. So we use that data set for that reason, for factor plotting. Okay, next. Another thing that I wanted to cover in this video is how you can do the data processing. So I have here, okay, the codescape for data processing. So definitely, I'm going to start to drop or remove one of the non-influence, okay, or the one of the features that will not really directly influence the survivability, which is the passenger ID. And we just saw it from the trends here that it doesn't have, okay, a direct effect, okay, a direct effect on survivability. So we're going to remove it now, okay? But we're not going to remove the others, okay? The other features, okay, at this moment because we need some uh methods to do, okay, for data processing part. Next, we're going to start with the missing data. Okay. Since we have seen some missing data on our data set, then we'll need to supply a better value on those. So we're having pieces of puzzle or maybe fixing the holes in our house, okay, in this kind of method. So in terms of missing data, it is really necessary to fill in the missing data values in your data set. As most of the machine learning models, okay, that you will use will definitely provide an error if you do so. And if you passed an NaN or not a number values into them, that will be a problem. Okay. So the easiest way is to definitely naturally handle the missing data in Python by by just filling it with zero. But it is essential to note that this approach can potentially reduce your model accuracy significantly if you do a zero. So definitely, if you wanted to find some other techniques, definitely you'll have different answers coming from data scientists and also web resources, okay, about this. But I'll tell you mine. There are actually five, okay, methods that you can do for the data with missing values. So number one is definitely to fill in the data. Okay, and that is again what I mentioned a while ago, maybe zeros or one, okay, to fill the data. That method is what we call as data imputation. The other one, number two, the method is to delete the column with missing values. Again, take note that it can potentially reduce the model accuracy significantly if you do that. Number three, definitely if we can remove the column, we can also delete the rows with missing values. And again, we expect some caution, okay, regarding with that because it again will potentially reduce the accuracy of the model. So that's number three. Number four, you can do interpolation, which is actually what I'm going to do. Okay, we're going to estimate the known values, the unknown values using the two known data points. Okay, and that's what interpolation. And the number five is actually not part of this, will not be covered in this video. Number five is to run a regression analysis for filling in the missing values. Okay, so there. So what I'm going to use is an interpolation, just like what I said a while ago. Well, let's say let's try to look at the data set once. Once again, I have here prepared the data. Let's say if we have a value of 1 to 5, the users are about to enter that value and they have some missing values, then definitely we need to fill in the values that might be around 1 to 5 value respectively. So those are the 2 points or key points, okay, that we have to remember. And definitely, in order to complete the interpolation, you need to have statistical tools. Okay. Number one, you can actually have mean and standard deviation. So if the mean was calculated as 3.5, then definitely you can say it's around between the 3 and the 4 value that you can fill into the missing value. And then you will also need to observe what's the computed value for standard deviation. If it's something like 1.2, then definitely that means if you're going to fill in the value, it must be plus or minus 1.2, okay, for your mean. So let's say we have to fill in an instance number one, let's say a mean of 3.5 plus 1.2, okay, that will be 4.7. Another instance is to have your mean, okay, plus 1.1. So that will be valid because 1.1 is under the 1.2 standard deviation. So it can go lesser than value. Or you can have it like this, 3.5 as the mean minus 0.09. So that's actually 2.6. And that again is valid. So you can say that the value is valid because they use this 2 point, okay, for filling in the value, okay, the standard deviation and the mean. So how do we do that programmatically? We need a help of randomization, okay? Later on, we'll do that. But for now, okay, we'll try the missing data filling in on the cabin feature. If you happen to remember, the cabin was actually having a lot of missing values on it. Okay, so let's stop sharing again and then go back to the data set. So on our code, we have this missing data, okay, for the deck, for the cabin, and they're going to set up a deck variable. Actually, this is a dictionary. Okay, we'll have A as the key. And this will be the value. B, value 2, key, letter C, we'll have a value 3, and so on and so forth. Okay, what's the main idea here? Definitely, if they do detect a cabin code that starts with letter A, they will replace it with cabin a value of 1. Okay, if they detect a letter B, then they will replace it with letter number 2, so on and so on and so forth. So that's actually the goal with this. Okay, we use this for categorization purposes. Okay, so there, as you can see here, I'm running a regular expression here that detects if a letter starts with a lowercase or an uppercase letter. Okay, and then try to search it in the group. Now we have here, we're going to map 3 lines to map the deck, okay, from the cabin. Definitely, we will actually fill in, okay, those values, okay, with 0. Those who are having null values will be filled up with 0 at first. And then this time definitely um we'll definitely change the data type into int. Now that we are done with the preparation for the cabin, okay, and the deck, we're going to drop or remove the cabin feature from the 2 data set that we have. So we have the train and the test. Next, we have here the standard deviation. Okay, so we're going to definitely use that mean, standard deviation, okay, computed values for the age, okay, which is actually the one that we have seen from the data set that having missing values. So we're going to run a randomizer, and we'll have to make sure that it's an integer, okay, so that whatever the value we came up here with this randomization scheme under the random int parameter, it will still be an integer. Okay, so we randomize the age to fill in those blank in consideration between the mean, standard deviation, and is null. Okay, so there. Now that we are ready with the randomizer, then we can actually apply it onto the age. Okay, this is actually one of those lines that implements that. And with that, we accomplish everything by having the data set be set to an integer data type. So it's now on an int data type at this point. Okay. Then next, under the embarked, we only have one value that is missing, and we're going to supply it with uh, what at least much more value that is nearest to the most commonly used value. In this case, we have the letter S, Southampton. Most of the passengers were able to embark from Southampton. So if there is actually a blank, we're going to supply it with letter S. Again, the data type at this point is object. So this is actually the code for replacing the blank under the embark with the most common. So here's the common value that we have tried here. Okay. Next, again, the common value is S. So this is actually what we are passing here. Now, if we have to get the information again about the data set that we have, we can see that the deck is already now there added, but the cabin is now being removed from the list. Okay. The age is now still integer in 32 now. Okay. And the embark is still an object, but now it's having complete value now. Okay. Having a complete value regarding with the null or missing values. So we still have some other things to do here. We still have some objects here that we need to convert into int. We also have fare here and embarked here. Okay, so we're going to work with that. Okay, using this lines of code. So here we're going to change the fare. Okay, and change it to what? An integer. We're going to count all the missing values here, okay, under the fare, and convert it into an integer. Next, here we also do use categorization on the titles. Okay. Yeah, so definitely there's this key for our dictionary. We're going to change it into one. If it's a miss, the number two. If it's a misses, we'll have to change it into three. If it's a master, four, and rare as five. So there's actually what a way for us to extract those and be able to replace it. Okay? So here we have this line to replace the titles with more common title or as rare. So we're going to replace it. Okay, these are the other words that or strings that we will encounter: lady, countess, captain, colonel, don, so on and so forth. Reverend, sir. We also have miss, madam, mrs, and so on and so forth. So we're going to convert that. The main goal is definitely to convert it into numbers. Okay. So we're going to map it using the titles and fill the the values that are NaN or not a number with zeros. Okay, to play safe mode for to make it safe for this training. Okay, so we're going to fill in first this with zeros. Okay, if that is the case. With that, we can now safely drop the name because definitely having a name of Miss or Mrs. is not really a guarantee that they will survive. Okay. Okay. Definitely we'll have to find the we'll have to remove that, okay, on our data set. Next, on the genders that are not really in numbers, we need to set it into its category of zeros and one. Okay. So here's actually a code that will change the genders into numbers. Okay. Next, we also try to describe the ticket this time. And there are actually 624 tickets, but actually having 508 unique values being seen. So uh, in this line of code, we're going to drop the ticket, okay, for both data set. And here on the ports, since it is related on the embark, okay, we're going to change that as Southampton and the code letter C for Cherbourg and Queenstown, okay, into numeric values, okay, 0, 1, and 2. Okay, and this time we'll have it mapped for the ports that we have created here. So instead of having embark, we now have ports being mapped. Next, here we will now categorize the age group, the age values, because definitely what we have seen from the the data set that we have a while ago, there's still 71 years of age. So definitely some might be too old, some will be too young, okay? And definitely we'll have to group them so that it will be easier for training the data later on. Okay, so this is actually where is it again? This is actually our code to do it. Okay, so in here we created age categories that if they are age of less than 11, they are under category 0. If they are age uh, el- greater than 11 or 12, okay, 12 to 18 years old, then their age is under category number 1. And the age of the greater than 40 to 66 are definitely at 6. Okay. So definitely if you wanted to change this, definitely you can do so. Okay. Greater than 6, I can change that to 7 by now. Okay. So this time if we are to run this, okay, we'll have a different category now. Okay, for a while. Pause for a while. So if we try to rerun this output, since we change our our code due to some typographic error. Okay, we now have here. So we have three instances of the age group of greater than 66. Okay, and we have more of in the age group that is actually greater than 33 to 40 years of age, which is actually near to what we have seen a while ago. Age group of 3 and age group of 4 are of highest survivability. That's what we have seen from uh, the analytics a while ago. But then again, this is just counting the age group. Okay, so this means that if they are in that age group and showing higher numbers, that means most of them are definitely okay. The frequency is telling us okay on that age group. Next, if we try to run a head function again for at least 10 records to be seen, we can see that the age are now categorized from 0 to 7. The age group, the genders now 0 to 1 now. Same as with our survive that is 0 to 1. So the gender is actually 0 to 1. P class is still 1 to 3. On the embarked, it was changed into 0 to 1 values. 0 to 2 relatives are the one that we have created a while ago, the new feature, and not alone. They are all starting from the relatives up to the title. Those are newly created features. Okay. Next, here we're going to change this fair uh, feature because definitely we can see a high variability on the values that we have here. So we have 7, 8, and then spiked up with 71 and 51. That is actually not a good data that we are seeing. So we need some pre-processing on this. Okay. So here we have the same code that we have done with the age group, changing the fare into category of 0, 1, 2, and 3, and 4. But you can actually change this according to your will. No? Okay, next, let's try to create new features on our data set. Okay, this time we'll have our data being prepared once again for the age class and the age. Okay, so the age class is equals to the age times the P class. We're going to do that, okay? Because definitely the age class is actually being measured with its class ticket. And here we have the fare per person. We divide it into the relatives. Definitely, if they do have relative, they'll have to divide it to per head. Okay. And once we're done with that, we need to make sure that is of type int. Okay. And when we're done with that, we can run that head method, at least 10 to be seen. This time we get to see changes on the fare. Okay. And also the where is it? There, the age class and fare per person is now being seen as the newly added feature. Okay. So those are the two features that are being added. And with this, okay, if you wanted to, you can actually add more features to be able to explore this data better. But at this point, it can be now be ready. This can be ready now for machine learning model, but it's not covered. But that is not covered in this video. Okay. So with that, I hope you learned a lot from this video tutorial regarding EDA of the Titanic dataset. So with that, I hope you are now equipped to embark on your final projects. Thank you very much, and I'll see you again on our next video. Thank you. This is now Doc Jello, now signing off.